On air. Hi everyone, my name is Ev, and today we're gonna talk about very interesting topic, security. And this is gonna be the talk about security from developers' perspective. What we as devs can do to secure our applications and why actually to do this. Let me share my screen. I believe it will be sufficient to share. Oops, I'm sharing something certainly wrong. All right, let me share this. Can you guys see it?
Yep.
Incredible. So let's go ahead. Security. The first question which I'm going to actually ask the people in the call is why? Why do we need to write secure code? Why do we need to secure our application? And I'm not going to move on until I hear your thoughts, guys. So unmute, step in. Why?
Because otherwise your secrets get stolen.
Nah, who cares?
Regulation, GDPR?
Probably closer, yes. Yes, that's one of the reasons I would say. What else? What do you think? If I write a code with holes or they don't care about the security, what is the worst case scenario? What may happen? Or what are we trying to protect?
Somebody can steal
data.
Brilliant. I've heard the voice of wisdom. We want to protect data, and like Anthony mentioned, related to GDPR regulations, we want to protect people, right? So that's all security is going to care about. Business critical data, obviously, nobody wants their data to be exposed to others because the data sometimes, certainly for some companies, is very valuable. And it can be even business critical. If the data is exposed, the business can stop. You want to protect people, which means their personal identifiable data. That's related to GDPR regulations. Nobody wants to have your personal identifiable data stolen. Like, think about yourself. Imagine you buy, I don't know, a pizza on the website. You order a pizza, you put all your personal data there, and then it gets stolen. You wouldn't feel good about this. That's for sure. So that's how you should treat other people as well, other people's data and their identities. This topic, which became very popular these days with the social networks, when you don't want some actions to be taken on your behalf without you being involved into them, right? So that's what we should care about, and we care about. But does it mean that the only thing we have to care about is data? If you protect the data, if you secure the data, does it mean we're good? Of course, yes, with one note. If you will agree with every hacker in the world to do not ever try to hack your projects. So the truth is, of course not, because there are many, many layers in securing the projects, and the data is just one part of that. The data is the goal, is like the target which we want to protect. But it's not only about security of the data. Let's talk about this right now. So the phrase which I keep telling to all our clients and developers is that security is never-ending exercise. There is no point, there is no moment in time where we can stop and say, you know what? We've done everything that we could to secure the application. Now we should just relax and focus on features. For good reasons, because there is always new code which developers write or somebody else write, like server updates, update of the software, update of the tools. Oh, that was the second point. New tools, which always mean new vulnerabilities, or you can find the world, the community may find vulnerabilities in the existing code, even if you haven't changed the tools or the code, which always means new exploits. So there are always gaps or vulnerabilities in your application, regardless of new code and new tool, as well as and especially with the new code and with the new tools. So, is it the right time to get into panic mode because we know that we are always going to be vulnerable? The answer is no, because we know how to handle them. For the past 2 weeks, I was trying to rethink my approach and my way to think about security stuff. How do we handle security? What should we focus on? Like I said, the first thing which we should care about, and the only primary thing which we should care about, is securing the data. But there are plenty approaches to achieve security of the data. One of them is to write secure code. All these security tips and tricks we learn from Drupal world, from JavaScript community and stuff like that, is just the quarter of what I was able to think of in terms of security. So writing secure code is a very big exercise, but that's still a quarter of what we should be really care about. Because apart from securing code, what we could do and should do actually is mitigating the consequences. If something went wrong, like horribly wrong, and your site was hacked, you should be ready for this. And we're going to talk about all these items in a few minutes, all these points in a few minutes. So I'm just going to enumerate all of them right now. Apart from mitigating consequences, the next one is limitation of vector, a potential attack. And this point is about trying to make hackers' job and hackers' life more complicated. Because, as you know, quite often there is hackers find one small-ish vulnerability, and then they try to exploit this vulnerability to get and try to find more vulnerabilities in your code through this one. And that's what I call a vector of potential attack. When one small thing leads to another small thing, which eventually leads to a serious problem. The fourth point is actually securing access to databases which hold your data. So there are 4 layers, 4, let's call directions, 4 measures we should take to secure the applications. Let's talk about each of them. First one is kind of obvious because the presentation title was security from developer's perspective. So we're going to talk about writing secure code. But thank God, this talk is not about writing secure code. So I was able to limit myself to just 2 points. One of them is follow best practices, which is obvious item if you put this in presentation, and but not always obvious in practice. There are good reasons why frameworks which we use, like talking about Drupal, for instance, why they have best practices, how to write a form, how to expose an API endpoint, how to output a data. Because most likely, people in the communities have already thought about security for you. And if you're going to use the API of the recommended API of that framework, these security items, many security issues are already covered for you. But obviously, and if you're doing something custom, completely bespoke, and like trying to print out bare HTML with form, you're likely going to leave a few security issues there as well, because you haven't thought about like cross-site requires forgery stuff, about potentially validating inputs and so on and so forth, which community have thought about already. So that's why following best practices is quite important subject in relation to secure code. Second one is thinking critical. I found that I've seen this quite often When developers write code, they genuinely believe that users will put a number in the form because developers ask them to put a number there. Here's the form which has a text field and the label says, please put here your mobile phone number. And developers believe that users will not put their SQL injection, that they will not put their piece of JavaScript. They will be putting there only the data which is assumed to be there. But I want to remind everyone that we are developing for web, and our work is actually accessible to billion people in the world, which leaves a little chance that somebody will try to put something into the forums, into the URLs, into whatever. That is not what we assume. That's very important to keep in mind. Therefore, my wholehearted recommendation is to think critical about the code which you write, because it will not be used as you assume it's going to be used. One more thing. When we talk about writing secure code, there's one more source which I would like to mention. Have you ever heard about OWASP? Who knows what it stands for? Huh? No, no one.
Yeah, I think I know what it is about, but I don't recall how the full name. It's basically web standardized web security resource. They have Open Web Application Security Project that collects best practices for top N, maybe top 10, maybe top 100 web vulnerabilities and how to protect against them.
Yeah, that's
probably also have some resources about how you can automate checks against those vulnerabilities.
Cool. Yeah, that's quite accurate, Kate. So basically, it's a source of information for best practices, how to handle certain security aspects in relation to development aspects. This project has a very, very good cheat sheet, which contains a lot of documentation, how to handle these, how to handle that. For instance, I recall a few years ago when we did authentication from the front-end application to the back-end application, and it was the first time we did this. We had to base our work on JWT tokens. I wasn't quite sure how to handle security with those tokens, because it's a very sensitive topic, a very sensitive piece of data, because it runs the access to the backend stuff. So cheat sheet contains this information as well. They just clearly say, excuse me, JSON web tokens, that's how you should handle them. That's like the symptoms of issues. That's how you should resolve these issues. So it's a very good source of data for developers, which explains how to handle security in different cases. I do recommend to read it, literally everyone. So, consequences, mitigating consequences. Oops, I think there was a funny picture, but it's either not available or something is broken. Anyway, then no more fun picture in the talk. The approach here to mitigating consequences is trying to think about your applications, your projects, as like you were already hacked, and the hackers already hold your database. What would you do different? And when you realize that the data from your database is in hackers' hands, you start going like, oh, probably we should not have stored credit card details in the database because we don't really use this. We just store it. It was easier from that perspective, but we don't use this. And now this data is in hackers' hands. If we would not store this, probably the problem would have been lesser than what it is right now. Or the second case, actually, we should not have captured passport details on the application, just order pizza. Yeah, that was a requirement from one of the stakeholders because they really want to know the passport details of those users. But do we really need to store this information all the time, even after the order was made, forever? Probably not. And you start thinking about these problems and these things only when the data leak actually happens. You realize that next time you're going to do this right, but try to think about this before it happens. That helps to think about the necessity of capturing data, and especially like capturing this data forever in a little bit different perspective. So, very clear message. Get rid of the data which you don't use or don't need anymore. Or don't even capture this if possible. Anyway, going ahead. Let's talk a little bit about the limitation of vector potential attack. And here, like I said, we're going to talk about how to make hackers' job more complicated. I did quickly touch on the subject on this subject before, and in most of the cases, you don't leave huge security holes in the code or in your application. You leave one thing here, another thing there, and then depending on what the hackers may find, they may find one thing, and then they using this little door, they try to get to the second door, to the third door, through other tricks, and eventually they get the access to the data. So our job as a developer is not only to write secure code, but also to make sure that we close as many doors as possible. So if one door is open, the second one is closed, and that's it, done. We might have got a nasty thing done by hackers, but they didn't get access to the data because we closed the second door, for instance. There are plenty of things to talk about in relation to limitation of vector of attack. One of them is definitely implement secure headers for browsers. They tell you how to load the resources, from which resources you can load the data, from which you can't, how to handle requests. It sort of tells the browser of users not to do something unwanted, because by default there are too many doors opened. That was a historical decision in many cases, but these headers, they can close many of these doors. Another good example is make sure that the file system is not writable by a user who handles your web server, because if somebody gets access to the server, I mean, from the inside of the app, that's good practice to do not let them modify anything on the server for various good reasons. It's very nice to understand how your application security looks from penetration testing tools point of view, because they kind of try to look at your application as well as the hackers. Like, what's the ports available on your servers? What are the headers available, and what headers we can. If there are some not secured headers, then probably we can use them, and blah blah blah, stuff like that. So it's very good to look at your apps from this point of view. I've specified one resource which I found particularly useful in penetration testing. It's Detectify. It's not the only tool, and there are plenty others, but I just personally enjoyed this one, and so on. So there is, like I said, never-ending exercise, but at least think about doors which we can close forever for hackers. And if we write a bit of insecure code, these doors should not let them go further. Access to database. That's a very interesting subject as well. So, the database. It may be stored, it is stored in multiple places. The first thing where the database is stored is obviously a server. And if your server is publicly available, then it is a potential security issue by default. In our case, in the case of System City, we have our server in a private network, and the access there happens only through like this private network. So apart from HTTP and HTTPS ports on load balancer, nobody will ever get to our servers. But that's probably not the case in other companies. So obviously access to server usually means, like if hackers get access to the server, it usually means that they get access to your database. And that's a problem. The second kind of obvious thing, but people, especially developers, quite often forget about this, is backups. Everybody think about the backups as something that you will unlikely need. It's stored somewhere. Probably somebody has access to the backups, but hey, backups hold all the data for your website. That's a snapshot of the database, of the whole data. That, as we know, can be business critical, that stores user identifiable information, and so on and so forth. So backups, access to backups, as much important as access to the whole server. Production side, we're going to talk about this in details in a minute. But basically, the site which is live, and there are billions of people which have access to it, and we have to secure it. And then, like I said, we're going to talk about this right now. The next bit, next part of the topic is our development environments, which, as we know, they're also publicly available. Obviously, we try to put this on the URLs, which are hard to guess, not something like stage.example.com, but something completely different. And we try to protect this data with HTTP authentication, and we do not enable things like admin by default on those development environments. And we have to bear this in mind, that developer environments also have a snapshot of the production site, of the production database. So those dev environments, they also have to be secure as much as the production site. Otherwise, we are in danger of somebody getting to the data through dev environments. Last but not the least is local dev environments. There are many developers on this call. They have laptops, and on these laptops, there are absolute copy of the production database running right now. Obviously, don't forget about this, that you're holding the whole the whole client's data on your laptops. So your laptops obviously have to be encrypted, and you should take the measures to secure this data. Like I promised, we're going to talk about access to database through the production website. And the way I think about this is that every user with the access to some private data is potential source of data leak. Every time we give access to our client, like a manager, to content editor, to whoever, doesn't matter, this user may potentially put a very weak password, or may put the password on a sticker and put it on his desktop, on his desk, and just leave it somewhere in a place where he doesn't want, well, occasionally somewhere which is accessible for third people, or just use the access from, I don't know, internet cafe and forget to log out. So every user is potential source of data leak. What I propose to set up for these users, obviously it depends on the project, but if that's possible, especially for staff members, which usually, of clients, which usually have much more privileges than other users, is to try to establish two-factor authentication for them, which is already kind of a standard in the industry. Set up login alerts. If you're using GitHub, you might have noticed this. They send you login alerts. You can enable two-factor authentication, and it really makes your code much more secure than it is by default. These two first things are, I would say, very important in reaching these security measures to prevent access. Because even if you lose your password or somebody else will be able to get your password, that's kind of fine. The first door is opened, but the second one is closed because there is a two-factor auth. And if there will be some unexpected logging, still you get alert. There are a few more things which are very nice to have. Password policies. Try not to, well, you can force people with elevated privileges to input something relatively secure rather than admin. I personally a little bit hating these password policies because they make the passwords really complex to to remember and easy to forget. But there are plenty tools like online services who can help you to remember those passwords for you. So probably it's not that bad thing. And the last item in this talk, in this talking point, is expiration. Another problem that happens with which is quite natural in the industry, is that people leave companies. New people come, old people leave, and it's not. And if the user, I'm just thinking about the best way to put it. If nobody cares about the blocking users when they leave, then these users, even though they don't work in the companies anymore, still have access to the website. They still have access to data. So automatic accounts expiration for staff members is also very nice to have thing. If people forgot to block the users from the system, then the system will do this automatically, which is a very nice thing. And this is the end of the talk. I hope it was very interesting, at least for some of you guys. I'm very open to questions and just talks and discussion.
I was sitting and waiting for you to talk about a tool called Routiny or something. Could you please share your thoughts on it?
Let me try to recall what kind of tool.
So there is a tool called Routiny. It is explained as automated site auditing or auditing.
Yeah, it wasn't really part of this talk because I wanted to a little bit change the direction of how we think about the security, and then the tools are kind of extra to this. Routiny is just the tool. I haven't been able to use it in production. I just tried it a few times. Oh, that's a different one actually, Kate. You might be talking about the other one.
No, I'm talking about this one. And the reason why I'm very interested in this, because it turned out that there are many best practices collected there, and they can be executed on a regular basis in CI. So you can, you don't have to keep all 100 best practice tips from OWASP 10,000, and you can run it and integrate it in the CI. This is something that I'm very curious about.
Yeah, likewise. so far, what I know is that there is a tool which you can build into the CI. I found it and I have never used it. But this is something like, I put this into the internal documentation to install and play with, because that's very interesting for automated auditing. And it can do more than the Drupal module called site audit. Because it's
yes.
Yeah. Because you can build your own easily. It's not only within Drush. It can do more than Drush can do. Let's put it this way, because it's not limited to Drush CLI or Drupal Bootstrap.
Okay, thanks. And another question I had is, you mentioned that we must be very careful about dev environments and local environments. Again, can we somehow put automated protection by sanitizing data, or like spinning up clean Drupal website with fake data or something like that?
Yeah, this is something I'm also thinking of, to be honest. Data sanitization sounds very good to me. It's called obfuscation in the right terms. When you clone the data from from production to other environments, it's very good practice to obfuscate all the critical data. There are tools which help you to automate this. I don't recall the name of the tool, but there are tools. So you can configure it even visually, like here's a source database, it goes through a certain pipe, follows in this pipe you can configure the criteria what to do with the data, how to obfuscate the data, in which cases you don't obfuscate, in which you do. It's a very smart tool. I forgot the name, unfortunately. But yes, this is something we should also look how we can implement this within our workflow for even better security.
Never ending security journey, as you mentioned.
Yes, there are always things to improve. Security and performance, never ending. I think I should stop sharing my screen for a second. Well, till the end of the call, actually. Stop.
This two-factor authentication you mentioned, it can fix like potential problems from the managers and editors who has some access to the data. Is it easy to integrate it to Drupal?
Yes, there is a Drupal module called TFA, which stands for two-factor authentication, obviously, which has the additional sub-modules in the ecosystem of Drupal, which you can just plug and play, basically. So that's quite straightforward, I would say.
Does it require any third-party services?
Well, yeah, obviously you log in through Google or you log in through something. There are web applications like I personally use, how's it called? Authy. Yeah. We use it for authentication into like AWS, into other stuff. Like, what else is here? Yeah, Cloudflare, for instance. There is no reason why we shouldn't be adopting this for our clients. And that's very easy. If they lose their password, or I mean, if they can literally put their password on their T-shirt and walk on the street. It's not going to be an issue, a security issue still, maybe a little bit. But two-factor auth can actually rocks in these regards.
Now, what's your take on management of keys and something like the Terraform guys came out with Vault? What do you make of that stuff?
That's a question which I can't answer because I haven't used the Vault stuff. I'm always a little bit concerned when somebody stores all my passwords somewhere. That's probably me being a little bit was the right word. Skeptical about the security of those tools who hold my data. So I would like to hear somebody else's opinion about the Vault and these kind of tools.
So would you say password managers or any tool designed to protect secrets, protect keys, because it consolidates all of your risk into one tool, that's the problem? Are you trying to limit your blast radius when there's a security issue because you've kept all of the different passwords, all of the different access very separate from each other? Or does the benefit outweigh the risk? And if you've got everything in one place, is it easier to secure one thing?
It's a good question. And I'm sure there's no right answer because it's kind of depending on the personal take on that. So I'm pretty sure that some people consider the usability kind of higher, more important than the security. And in this case, and they probably hand over the responsibility for storing their keys to somebody else. Like, I trust these guys to store my keys there. That's their job, and I would want to just get a usable way to like remember all my passwords, or like keep all my passwords in one place. For me, I'm a little bit freak in these regards. I try to keep all my passwords in my head. It kind of trains.
Do you have one password for all services?
Yeah, it's my nickname 123.
What about project-specific secrets, which are not your personal passwords, but like, let's say, API keys, some keys for encryption, encrypting something in the project. So basically, you can just store them in plain text. And I believe it's not best practice at all to keep anything sensitive in plain text. Or you can use some third parties, which you mentioned, that provide some tooling and say, okay, just trust our algorithms. You can self-host them in Docker containers or somehow, but you basically rely on that third-party tool and trust that it is encrypted. And unless you are like a geek in this field and you really understand how encryption works, you can't check it. You can't ensure that it is really secure. You can only read an article where it states, yes, it's really secure because it's a AES 256 or something. But you, how to like, if you are a complete newbie in this field and you don't have a security engineering background, how you get started in this, in solving these problems?
And do you want me to give you a smart answer to this very complex topic right now? I don't have a smart answer, to be honest. You have to trust them too. Try to pick the biggest names in the industry. They're likely more secure, but at the same time, it's very likely that there are more people trying to hack them because they're the biggest in the industry. It's a two-sided coin.
And as you said earlier, one of the things you want to do is mitigate against, just imagine that there's an inevitable situation. So inevitably you get hacked. How have you kept data safe? Well, you encrypt personal data on the back end, or you get it out of the system as soon as it's in there, so it's not stored in multiple places where it doesn't need to be. And if you carry out those best practices, then you do what you're able to do in terms of mitigating against the security hole in the first place. But should it happen, the risk is minimized. Yeah.
Right, mitigating actually the consequences is one of my favorite thoughts and topics. Imagine you're hacked. What would you have done different? Are there any other questions, guys, or talking points?
What about emails? Because it's very security is access to most of sites very depends on emails, and if someone have access to email, he can get access to many applications in the web. Probably we have some solutions for solve this problem.
Well, luckily, we are not the people who develop email services.
Yeah, but probably we
Authentication. I don't know if the world.
only with two-factor authentication.
I don't know if the world has invented something like smarter than like either authentication through your like password and something else, like and either sending your SMS or through like applications like Authy and so on. There's a second step in verification that it's really you, but I don't know if there is anything else apart from that which could secure additionally the access to emails. But that's a good point that emails hold lots of sensitive data. I mean, and you can restore a password to that email. If your email is stolen, that's it as well. That's it. Yeah, welcome. That's even bigger issue because likely you have different websites with users on with this email. So that's even bigger issue. All right, shall we leave it there?
Yeah, thanks, Ev. That's very good.
Thanks.
Yeah, thank you, guys.
Thank you.